Hello everyone and welcome back to another construction surveying lab. Today I'm gonna talk about tunnel station. So basically what I did previously was we had two labs, introduction to total station and the total station closed traverse. So in the first one, the students gain familiarity and develop their skills, how to use the total station, set it up and level it. And then in the second lab, basically they focus on the report, how to collect the data and how to prepare the report. However, given this situation, we combined these two labs and we shifted our focus a little bit. I'm gonna demonstrate to you how to use the total station, how to set it up, how to measure single angle, double angle, and also distances, but the report or deliverable out of this lab would be different this time. I'm gonna talk about that later. Okay. So the objective is gain familiarity with the operation of a total station. Obviously, when I demonstrate to you how to do that, you will to some extent gain that familiarity. You're gonna understand and gonna be able to perform the total station setup procedure and learn to set up over a point and level the total station. So here you may notice that it says over a point. So when we did leveling, the goal was just know the benchmark and point of interest or turning point, and then we wanted to set up somewhere roughly halfway between the 2 points to cancel out the error, right? But we never marked the ground, and it was kind of a free selection. You could have like moved it here or there or anywhere you wanted. But when it comes to total station, it's totally different. The main difference of setup procedure is that we set up over a point. So a point, let's say a nail is given with the like here is the head. I'm looking top down or bird view. So we want to exactly set up over this point, not here, not here, exactly over this point. You'll see that there are some challenges and difficulties. Okay, just keep in mind that we want to set up over a point, because if we are able to find the coordinates of this point and then the direction of the total station or the north, let's say the north, then the total station would be able to calculate the coordinates of any point that we should. So we should here, let's say we should here, it automatically will calculate the coordinates for you. But we need to know how to set up over this point and be able to introduce these coordinates to the machine. Number 4, measure distances and angles using the total station. You see that in a matter of seconds you can measure distances and angles, and you're going to learn how to develop contour maps. So this is something that was added specifically for this lab. So you're going to learn how to do that, because the data will be given to you, and then based on the data you'll use these you're going to develop the maps. What kind of equipment do we need? Obviously we need a tripod to be able to set up the machine. We need a total station. The total station needs a battery. It's a very essential part of the machine, and you need to take care of that. Make sure it's charged. When you go outside and do the surveying, especially if you do professionally, you have to have a spare battery in case that your battery fails or it dies. Then you have another battery to continue working or surveying. A rod and reflector and Plumb Bob. So you might think, why do I need a Plumb Bob? Most total stations have a laser plummet that gonna send a laser down to indicate or to project the total station point. So, and the goal is to make sure this laser plummet is exactly on that nail, right? But if your machine is very old, it doesn't have that laser technology, then you can use a Plumb Bob and hang that Plumb Bob to point to the setup point. Okay. A nail, because you want to find where you are setting up, then you put a nail to kind of mark your point. It cannot be just like marking with chalk, because accuracy matters, right? We typically went here, the same area that we conducted most of our labs, but they gonna give you and provide you might be different location. Okay. So this is the procedure for the previous labs, like the traditional one, that a three-sided closed traverse in the area was selected, and then the student had to mark the corners and 1 point on each area. We subdivided each of these into one areas. Let's say these 1, 2, and 3, to make sure that the the traverse area is spread out. Students had to pick 1 point in each area, and then they had to set up the total station exactly over the point. You'll see the point of using nail, because let's say you have 3 corners, right? We go to the next one. Perform a double angle and measure the horizontal distances of the 2 sides. So what was the plan initially was that, so let's say this is point 1, 2, and 3. So the first setup was on point 1. Then the students had to hold the rod on point 2 and on point 3. By doing this, they were able to measure the distance of these 2 sides and also this angle, right? Then they would have moved their equipment and set up over here, set up 2, okay, and then hold the rod on this point and this point and shoot to these points, right? Again, measure the distance of the sides, and you'll see that if there was no nail, they could have not done this, right? And once they also do the setup number 3 for each side, they had 2 measurements, okay, and they could have measured the error ratio that you are familiar with, and also for each angle they measured single angle and double angle, that you know how those are measured, and I also demonstrated the measurement. And they had to make sure that they rotate duty, so 3 sides or 3 corners were selected, because basically students were assigned to groups of 3. Then each one had the opportunity to become familiar with the setup, holding a rod, and filling out the field book. But as I said, we are not able to do this given the pandemic, but we can learn something out of these. For this one, distances and angles of 100 points, roughly. It could be more or less. Points will be given. You're gonna assign these points, and then the corresponding elevations also will be given. You need to calculate the coordinates of given points and draw the contour maps. You might say, wow, how should I do that? You're free to use any kind of software, and if you search on YouTube, there are a bunch of videos that you can find. You can use AutoCAD or other software programs that are free, and you just feed the information, the data, and it generates the contour maps for you. Then you need to submit that. Okay, it's it is your choice on the intervals, however you feel it's needed, 1 feet, 5 feet, 10 feet, etc., depending on the nature of the points. So it's up to you, but you need to practice and learn how to draw contour maps. Okay, if you have any question, just let me know. Feel free to shoot me an email or meet me during office hours. Now let's watch the demonstration in the field. As you see, we all have masks. We are wearing masks, which means we are recording these videos during the pandemic 2020, and we had to switch the labs to be online. Obviously, these cannot replace the experience that you could have gained having your hands on the equipment, but obviously this is better than nothing. We try our best to give you the highest level of quality for education and demonstrate the details of labs that you can learn maximum out of these videos. Okay, today is a sunny day and the weather is 86 degrees. As you know, we need to report the temperature and weather as professional surveyors because it impacts our results.
Lower station is the setup is basically similar with having some more steps, because for total station what matters is not just setting it up and make it level, but also make sure it is set up, it is level, and it is exactly on the point. Okay, so you unbuckle this. Okay, you unbuckle it. Make sure squeeze the legs. Okay, then lose these legs. Way that you can easily adjust. Okay, based on your height. Okay, then height. I think it's good for me. You firmly place them in the ground. Okay. Then you open the box. And grab the whole station. Yes. You need a battery as well. Thank you. Charge, place it on top of the tripod. Let's do it. Screw it. Then make sure this time it is in center. Okay, we'll see why this matters later. It has to be in center. Then you tight it. You've got 3 knobs. Similarly, you rotate them until you see the dent, the mark, the line. We do this for the 3 one, all the 3. If you skip this one, then it's gonna be a lot of hassle without being able to get it level. Next step, you insert the battery. Push it quick and turn it on. As you can see, when I try to rotate it, it resists. point that we want to set our total stations, because in total stations we can also measure the horizontal distances, and for horizontal distances we need to know where our total station is set up. Okay, I got another nail over there, or that's gonna be my next point. One over here, that's fine. And once you place this battery in and push it, you can turn it on. Good. You can turn it on, okay? When you turn it on, you need to make sure it is level. And if it is not level, it wouldn't let you to use it. So each total station would be different, but basically what you need to do, go to menu, and then you see it got 4 keys: F1, F2, F3, F4, and it shows here which key would do some functions. F1 data collect, F2 layout, F3 memory manager, and F4 goes to the next page. So you got 3 pages, page 2 out of 3. And then now F1 goes to programs, F2 grid factor, and F3 laser plummet. We need to turn on the laser plummet, and when I do that, you see some lasers. Do you see this red dot? So this laser plummet has to be on top of the nail. Now you can see it is off the point. Do you see on my shoe? It is off the point. So at this point, what you need to do, grab 2 of the legs, get one of them fixed, okay, and make sure it is on. Okay. Okay, it's right here. And then you move it until you get this laser plummet center of the head of the nail. Okay, once you do it, you push these 2 legs hard into the ground. Okay. Now still the laser has to be on the nail. Okay, but it is not level. Okay. It got a level, a bubble level. So the same thing. It would be better to play with legs first. So it's like this. That means that I need to bring this down. I bring this down until it is, if it is, the bubble is somehow inside the inner circle, then that's the stage that you can grab these knobs. Okay. So I grab these 2, rotate inside or outside until it is halfway between these 2. Okay, not close to each of these, but the same distance. At this point, you grab the 3rd one and you make it right in the center. By doing this, now your point might be a little bit off the point. That's the step that you need to unscrew this total station and move it slightly. That's what I said. You need to make sure when you set it up, it's in the center of the top of the tripod. If it is not, then you would not be able to move it. Okay. Now I see that it is right on top of the nail. You tight it. You make sure it is still level. In some cases, you need to do this several times until you get this fully level. So now it is exactly on top of the point and it is exactly level. Now I'm good. Okay, can you show that this is also level? First thing that I want to do is make a measurement, a horizontal measurement. You can see that the telescope, I can rotate it horizontally and vertically. Okay, so it's the same thing. You need to look through these. Okay, let me look.
First thing that you need to do is to focus. First focus the crosshairs, and after that focus the telescope itself. Next point is to find the prism. So if you have difficulties to find the prism, you can look through the optical to find the approximate location. After that, you can look through the telescope and find it. Then you can lock the total station to move vertically and horizontally and use the knobs for only fine adjustments once you find the prism. Okay, then next step is to take the measurement. If you take a look at this total station, you see that it has on the right side 6 bottoms, and the middle one on the left is like a triangle. So if you hit that one, it measures the distances and it gives you the horizontal, vertical, and slope distance. Before you hit the measure, you make sure that your rod person is holding the rod correctly. The rod has to be exactly on the point, as you can see here. So once you have the rod, the next step is that you focus and look through the telescope to find your prism. It might be tedious to do so, but you need to be patient. First, try to find the approximate location of the prism, and then look through the telescope, focus the crosshairs, focus the telescope, use the knobs to fine adjust until you can see that the crosshairs are on the prism. Once you can see that, then it's time to shoot and record your measurements.
Okay, once you can see that, then you press this triangle, so it got it shows horizontal, vertical, and slope. You press that and press F1, which is measure. Okay, until you hear this beep sound, and it gives you the horizontal distance, or HD. It's 35.705, so 3 decimal places. And vertical distance, it's 2.705. It measures from the center of the telescope, which is right here. Do you see this dot and 2 kind of dashes or lines? Then you can press P1 or press this one more time. It also gives you the slope distance, SD 35.805. So it measures the horizontal, the vertical, and the slope distance, and it gives you that. Another thing that you can do is measure the angles. Okay, so we need to, for the sake of accuracy, we need to use a Plumb Bob to measure our angle. So let's grab this Plumb Bob, and for Plumb Bob it would be better to just sit down to limit the swing that it might get, and then hold this tip of the Plumb Bob on top of the point, and then ask your surveyor to look through this string and then match the crosshair with this string. And once it is matched, I will show you how to measure single angle and double angle. Let's start from this one. So we start from the point on the left. Okay. We start from the point on the left. Look through these. Make sure it is not. Okay. You look through these until you can clearly see that. And lock it, rotate for fine adjustments. And once you do that, you press this angle button, and it has, and set it to 0. Okay, it asks if you want to set 0. You set.
It is set to 0. You started from the point from the left side, then you go to the right side. So you ask your rod person to hold the prism on the point on the right side. Once it is in place, then you look through the telescope, find the string, try to match the crosshairs with the string, and then you just read what you see on the screen of your total station. So my point is 92 degrees 38 minutes and 56 seconds.
Okay. This is my single angle. For double angle, I need to flip this telescope. Okay. Flip this telescope 180 degrees, and then rotate this, and then shoot to the first point again. Okay. I shoot to the first point again. Once it is in place, position. I lock this. And I need to come here and bring that. Okay, 182 degrees and 52 minutes and 25 seconds. The same direction, I again rotated to the second point. So that was transited A or transited 1, and this one is transited 2. Okay, I again shoot to the point. Okay, I shoot to the point, and then read that. This is 276 degrees, 31 minutes, 25 seconds. Okay, then it would be my transited 2. Transited 2 minus transited 1 plus single angle divided by 2 would be my double angle. Okay.
Let's have a closer look and review the procedure one more time. Look through the telestation screen.
Okay, now you press angle. Now set it to 0. Do you see F1? 0 set? 0 set? Okay, yes. It sets to 0. Do you see horizontal angle is 0? And then you keep rotating. Okay, you rotate and you see that it changes. And if you lock it, this light rotations, only the minutes and seconds would change. And you read these horizontal reading or horizontal angle, and that would be when you shoot to the first point after setting shoot to the second point after setting to 0, shooting to first point, it will be your single angle. You flip the telescope. Okay, you flip the telescope, then let me start over. Okay, you set to 0. Okay, you see with the slight change it changes. You then shoot to point 2 or point B. You flip the telescope, rotate, shoot to the first point, and then rotate to the second point and read your angles. It will be, the first reading would be 0, the second would be a single angle, the third one would be transited A, the fourth would be transited B. Transited B minus transited A plus single angle divided by 2, it would be your double angle. Once you're done, you make sure you turn it off, you take out the battery. It is very important to take out the battery and then place it for recharging. Then unscrew this. And put it in the box. Make sure again you put it in a way that you don't have to force it to close. Okay? Then you are all set. Oh, I forgot the Plumb Bob. You got the Plumb Bob. And charge the battery. Take the tripod. Buckle it. you're all set. Thank you.